Hi, my name's Bennett, and I love physics. Let's talk. Physics is everywhere in the universe, from the rock climber reaching new heights, to the archer shooting an arrow. Physics is merely the study of all matter and energy, from the smallest particles to the largest of stars. This is physics. I'm here to teach you about a very interesting science concept, the Lotus Effect. Named after Asia's lotus flower in 1977 by Bartlett and Eller.
Oh, heads up, dude!
Dang it! If only there was a way that my shirt could repel water. No, maybe there is a way. Here we have the lotus plant. My favorite thing about this plant is that it grows in murky waters. Yet when it grows out of the mud, it's completely clean. This is caused by a property called ultrahydrophobicity. Now, that may sound a little complex, but the concept is actually quite simple. First things first, vocabulary. There are a couple of basic words you'll need to know for this video. The first one is nanoparticle. What is a nanoparticle? A nanoparticle is typically described as a particle that is somewhere between 1 and 100 nanometers across. That's pretty small. 1 nanometer is 1/1000th of a meter. Now, I know it's a little hard to picture, so let's do some comparisons. I have here a 4-foot diameter beach ball. If an average nanoparticle were to be the size of this beach ball, a 5-year-old would be as tall as the sun. That's one small particle. Okay, so now we understand what a nanoparticle is? Good, let's move on. As you might recall, the Lotus effect is caused by a property called ultrahydrophobicity. Again, I know that sounds complex. It's quite simple, really. When something is hydrophobic, or has hydrophobicity, it repels water. It comes from its Latin roots of hydro, meaning water, and phobic, meaning fear of. So when I say the lotus flower is ultra-hydrophobic, it basically just means that it really repels water. There's also the opposite of that, which is hydrophilic. It's basically the term used when an object attracts water. The next and final vocabulary word I need to cover is contact angle. You see, contact angle is the angle at which a liquid touches a solid surface. It's kind of like this. You take a normal drop of water, shown by this beach ball, and deflate it slowly. You can see how contact angle is affected by the shape of the water droplet. Here we have our contact angle somewhere between 90 degrees and 180 degrees. Now it's somewhere between 0 and 90. And finally, we have this contact angle at approximately 0 degrees. So we can now see that the greater the contact angle, the easier the molecule will roll, because a fully inflated beach ball, which would have a very high contact angle, would roll much easier than the deflated ball, whose contact angle approaches 0. In this next example, people are representing nanoparticle pillars. When they are closer together, the water molecule, shown by this beach ball, simply rolls along the surface of the nanoparticle pillars, as opposed to when they are spread apart, and the beach ball gets stuck. So now that we know our vocabulary words, let's learn about the Lotus effect. You see, on the surface of the lotus plant, there are millions of little nanoparticle pillars that sit on the surface. At the nanoscopic level, it kind of looks like this. You see, as water molecules hit the surface of the lotus leaf, the water molecules are rolled up into little spheres. This is caused by the shape of the nanoparticle structures, and as we learned earlier, this spherical shape causes optimal contact angles, thus allowing the water to roll off the surface. Wait a minute, did we just figure out how the Lotus effect works? You see, that wasn't so complicated after all. Once we understand our basic vocabulary terms and the principles of contact angle, determining the cause of the lotus leaf's ultrahydrophobicity isn't really difficult. But wait a minute, this still doesn't solve the problem of my shirt getting all wet. Let's rewind. Turns out, scientists have discovered a way to apply the science of nanoparticles to fabric. There, that's much better. So in summary, we learned about nanoparticles, contact angle, and how these things affect ultrahydrophobicity in the lotus plant. I hope you enjoyed this video and learned something. Thanks for watching.